The universe could end today. No warning, no explosion. A wave of total structural collapse moving at the exact speed of light. Classical physics views the vacuum of space as an entirely empty void, a silent backdrop completely devoid of matter and energy. Quantum field theory reveals a vastly different environment. The universe is actually permeated by fundamental quantum fields that dictate how physical laws operate. The particles making up the physical matter we interact with daily are merely localized vibrations or temporary excitations within these underlying invisible fields. True emptiness does not exist anywhere. Our entire physical reality is an active construct built upon a churning ocean of quantum mechanics. In this framework, a vacuum state simply means that all local quantum fields are resting at their lowest possible energy level. It forms the energetic baseline from which all physical phenomena arise. The core existential threat to reality stems from one specific question. What if our current universe has not actually reached the true bottom of this energy scale? If it hasn't, the universe exists in a state called a false vacuum. It creates an illusion of complete stability, appearing permanent to us, while secretly sitting above a much deeper drop in energy. Human civilization, biology, and all known physics currently rest on a temporary, elevated ledge that is physically capable of giving way. The field central to this threat is the Higgs field. It permeates all of space and interacts with passing particles to give them mass. This graph shows the Higgs field's potential energy as a landscape. Our universe is a ball resting in a shallow depression. The adjacent, deeper valley is the true vacuum, the absolute minimum of energy. Trapped inside this dip, we remain stable against small, everyday disturbances. While our surroundings appear permanent on macroscopic timescales, mathematically, reality balances in a highly vulnerable position. The exact shape of this energy landscape is determined by measurable physical constants discovered inside complex particle detectors, like this one at CERN. The Higgs boson, weighing approximately 125 giga-electron-volts, constantly pulls the field's potential energy curve upward, attempting to stabilize our environment. Conversely, the top quark, the heaviest known elementary particle at over 172 giga-electron-volts, interacts strongly with the field, dragging the energy curve downward at high field values. When physicists extrapolate the Standard Model to extremely high energy scales, the specific ratio of these two particle masses traps the universe directly within a narrow band of metastability. The precarious nature of our existence relies entirely on verifiable, measured physical weights. According to the rules of classical mechanics, the universe is perfectly safe. It lacks the massive external energy required to push the system over the hill. However, reality ultimately operates on the rules of quantum mechanics. Thanks to the Heisenberg uncertainty principle, energy barriers can be bypassed. A mechanism known as quantum tunneling allows a localized region of the field to spontaneously pass straight through a solid energy barrier without ever possessing the classical energy needed to climb over it. If quantum tunneling occurs at a specific point in space, that localized region drops into the true vacuum, nucleating a microscopic bubble. The mechanics holding our reality together contain the exact loophole required to trigger its destruction. Once a bubble of true vacuum nucleates, the severe difference in energy density between the false vacuum outside and the true vacuum inside generates an immense outward pressure. This energy disparity forces the bubble wall to accelerate rapidly until it asymptotically approaches the speed of light. Because the destruction travels at light speed, it is physically impossible to see it coming. The interior of that bubble holds a completely different physical reality. The true vacuum corresponds to a different value of the Higgs field, instantaneously altering the masses of all elementary particles. If the mass of the electron or the quark shifts, the delicate balance of forces collapses. Electrons cease orbiting nuclei, protons fail to bind. Chemistry, molecular bonds, and biological life immediately terminate. The advancing bubble wall strips away the current fundamental laws of physics, incinerating everything in its path and replacing it with an alien, uninhabitable set of physical rules. While terrifying, quantum tunneling through such massive energy barriers carries an exponentially suppressed probability. Calculations of the decay rate indicate the expected lifetime of our universe in its current state ranges somewhere between 10 to the power of 100 and 10 to the power of 500 years. For perspective, the universe as we currently observe it is only 13.8 billion years old. The threat exists on a timescale vastly exceeding human comprehension. The precise masses of the Higgs boson and the top quark stabilize our field just enough to harbor complex biological life, while mathematically guaranteeing that life's eventual end. The stability we rely on every day is a temporary arrangement. We exist inside a highly structured, delicate anomaly, mathematically doomed to collapse when the clock eventually runs out.